One of the experiments that's going to be flying to the space station on board the Cygnus is the second iteration of the BASS experiment. That's the Burning and Suppression of Solids Experiment 2, and it is led by Dr. Sandra Olson, who's a Spacecraft Fire Safety Researcher with NASA's Glenn Research Center. And she's here on the line to tell us a little bit about that experiment today. Thanks so much for joining us, Dr. Olson.
Yes, thank you, Brandi.
So we're about to get a new set of BASS experiments on the space station. Can you tell us a little bit about the history of that and what we're looking for there?
Sure. Yeah, the BASS experiment ran last year, and we had a number of samples on board, and it was very successful. The crew really enjoyed running the experiments because it was very hands-on with the crew. And so we were given the opportunity to fly some additional samples. And we're using shared hardware that's been used for a number of investigations, and so we're really maximizing the science return on the investment of that hardware.
Okay, well, can you give us a little bit of information on what you've learned from the previous one and why it's a good idea to do another iteration, how you'll change it?
Sure. One of the things that the hardware does is it's a little flow duct, and it creates a controlled flow velocity, so we can study the effect of airflow on combustion in zero-G. As you know, fire in space is very different from what it is on Earth. Hot air rises on Earth because of buoyancy, but it doesn't do that in space. And so the mixing of the pyrolysis gases that come off of heated materials and mixing with the air in the space station, it's very different than it is that you would see on Earth. And so you would expect to get very different combustion products, things maybe more toxic in space. In addition, obviously you don't want to have a fire in space. It could damage the spacecraft, it can contaminate the atmosphere, and it could threaten the crew and the mission. So what we do when we do these experiments is we do it in a very controlled environment with multiple levels of safety. So there's no issue associated with the safety of these experiments.
And what are you able to learn from doing these experiments on board the space station as opposed to studying the phenomenon here on the ground?
We basically are looking and trying to study the flammability of materials, the ignition of materials, how fires spread over materials, and we're hoping to really learn a lot about how we want to screen materials in the future for exploration missions. So, because obviously, as you go further from the Earth, if you have a fire, that's a really bad scenario. So we want to make sure we fly the most safe materials. We make our spacecraft out of safe materials, and we fly all the stuff that isn't going to burn in the atmospheres that we're using in the spacecraft. What we have found to date is that it is very sensitive to the flow, and unfortunately the flow ranges of interest where the flammability is optimized are really those ventilation flows that you get in a spacecraft. And so one of the things that ISS was designed for initially, based on the research that we've done historically, is that if there's a fire alarm, they shut off the airflow in the space station to stop fanning the fire, basically. So that happens automatically when a smoke alarm goes off. And so that's one of the major impacts we've had on the safety of space station.
Okay, so you're already learning good information for future exploration and life on the space station as well?
Right, yeah. Yeah, the experiments that we're flying new samples up. They're going to launch this month. And we have 5 different investigation teams that are involved in the BASS-2 experiment. And they're looking at different materials, different geometries of materials, different whether they char or not char, and like I said, they're looking at flammability limits, when does extinction occur, how easy are they to ignite, and the main 2 variables we have, I mentioned flow before, but we also added just recently with the BASS ops in the spring that we did, we added a new variable of oxygen variation. We found we could vitiate or reduce the oxygen in the MSG working volume where we do the experiments using space station nitrogen. So we can vary the oxygen level, and that gives us a whole new and very important variable to study fires in space.
Why would you want to do that? Is that a way to extinguish it, or does it change
the oxygen? No, because if there's a fire, it's going to be consuming the oxygen, and so the oxygen will naturally deplete when there's a fire. So studying it in a controlled way where you have known oxygen levels and you can vary it, and then you know how sensitive it is to the oxygen. You can also get to extinction that way. You can, test and continue to reduce the oxygen until you find that extinction limit. And that's something we weren't able to do until this past spring when we realized we could vitiate the atmosphere in the MSG and demonstrated that it worked as we expected.
Interesting. So tell us a little bit about how the crew is involved in these experiments. What part do they play?
Oh, they're very integrally involved in the experiments. They're our hands and eyes when we run the experiments. We monitor it from the ground, but they're the ones who are really, doing the manual ignitions, taking the imaging, changing out the samples, calibrating the flow system, all that stuff. So it's something that they are very involved in, and they do really enjoy running the experiments.
That's great. Well, tell us, is there anything in particular that you're really looking forward to seeing when we get these experiments started again on the space station, or anything we should watch out for?
Well, we're certainly flying new samples that haven't been flown before, so we're really looking for some different configurations of flames and finding, especially with the thicker materials that we're burning, we're really hoping these are the largest thick materials that we've been able to fly to date. And so we're really looking forward to seeing how long it takes to reach a steady state flame or how long it takes for them to extinguish. We're really looking forward to, learning a lot of new things with these new samples.
We're always excited to see video of that experiment. It's so interesting to watch.
Yeah, they're very dynamic flames. They react almost instantaneously to a change in the velocity, which the crew can dial in. They have a little knob that they can turn the flow up and down, basically turning a fan faster and slower, and that changes the flow through the test section, and the flame reacts almost instantaneously to it.
Well, yeah, it's very cool to watch. Thank you so much for talking with us. Before you go, I wanted to ask, I just was interested in your title, Spacecraft Fire Safety Researcher. I'm guessing there aren't a whole lot of people who share that title. Is that true?
That's pretty much true, yeah. There are a handful of us.
How did you get into that field?
I just sort of happened into it when I hired in here. They had an opening in a very small group that was just getting started, and I was interested I had been working in combustion in aeronautics, but they said, we're interested in looking at fires in zero-G, and I thought that sounded amazingly interesting. So I've joined it, and I've been in that group ever since. So.
Well, it does sound interesting. Thanks again for joining us. We really appreciate it. And again, this was Dr. Sandra Olson from the Glenn Research Center, Spacecraft Fire Safety Researcher working on the BASS experiment. Thanks again.
Thank you.